Hello guys, welcome back to the channel and welcome back to the shop. It's been a while since we've been in the shop. We've been doing a lot of flying lately, and welcome back to our next unboxing and test run of the Zukoi X45 turboprop engine. Hopefully I got the box the right way. This is going to be a lot of fun. Been looking forward to this. This turbine is actually going in the Sebart PC21, and it's going to be replacing a Wren. So this video is just about the unboxing and test run of this engine. We'll also be doing an installation video on the PC21. So let's roll that intro and we'll get started with the unboxing of this amazing engine. Alright guys, well, this is how this engine comes, and let's open this thing up and see what is inside. We'll be doing all the weighing and everything of the components like normal, and we'll be doing some thrust tests on this thing as well too. Alright, so this is what it looks like. So we've got our foam packing, and we've got our accessories here, which is awesome. So I'm happy to see one of these bolts in there. So a bolt and a plate. We've got some Zukoi stickers. We've got the user's manual, the tiny little fuel pump, the brain or data relay module. Some would call this an ECU is what that is. So it's kind of an interesting design because it's got the built-in screen, but it's also got all of our connections for the engine. So I've never seen it like that before. That's pretty slick. We've got our standard cable set. So there's some fuel line in there. We've got a filter, all of our batteries, cables, and engine cables. And then underneath that, we have the turboprop. Wow. Holy! Alright, so initially with this thing, I don't know how this compares to the Wren, but before I even open this up, it feels, I'm going to say hefty, but it feels very, very solid and well built. I'll get some close-ups of these welds and stuff. It looks immaculate. Okay, so let's open this thing up. Beautiful. So take a look at some of those welds there, guys. It is, the craftsmanship on this engine is phenomenal. Now, compared to the Wren that this thing's replacing, I'm just shooting in the dark here, but this feels like it's a lot heavier in the exhaust section, and very, very nice engine. Now, one of the reasons the owner went with this engine is because the pattern here is supposed to fit with the Wren mounting. So the Wren has a circular mounting, and I believe these four are supposed to line up with 4 of the Wren mounting holes. So we will obviously confirm that when we go to install it. One of the things that initially I like about this engine compared to like the King Tech that which would be the last turboprop engine that we reviewed, if you look at the prop shaft. So the King Tech, when you put the back plate on, there is about 3 millimeters of material that's going to sit in the prop. This one, when you put your spinner back plate on here, you're still going to have lots of material that's sitting inside the prop. So way better design. We've got our RPM sensor there as well, right here. So that's a nice little treat as well too. But beautiful engine. So essentially you've got a 45, the Zukoi 45 strapped to the gearbox is how the turboprops work. There's a lubrication line which feeds the gearbox assembly, and very impressive little engine. Very impressed with this thing. I think it's going to perform great. So next thing we're going to do is weigh these components. Let's see how it all works out. All right, guys, so we will weigh each of these components individually, and then we're going to add up the weight all together. So the actual turboprop unit by itself is 1,671 grams. So for you Imperial folk, that works out to 3.68 pounds just for the engine itself. Then we've got the fuel pump, which weighs 29 grams. The ECU, or data relay module, which weighs 22 grams. The nut and prop washer is 36 grams. And we'll just do the entire cable bundle and fuel line bundle, and that is 65 grams. So all the accessories put together, you're looking at 156 grams of weight. And if we do the entire package together, that comes in at 1,829 grams, which equals to essentially 4 pounds exactly. All right, guys, if you are new to the channel, this is my portable turbine test stand. Now, this is set up for a normal turbine setup with the exhaust facing this way, and it works with my scale and everything. So we're gonna have to do a little bit of modifications to the setup. Don't know exactly how we're gonna get this attached, but we want the prop sitting here, and we want the prop pulling the turbine system. So we'll figure this out and see how she's going to mount. My buddy Joe made this for me. Thanks again, Joe. This thing is working out awesome. And anyways, let's figure out how to mount this turbine, and we'll do some tests. Well, guys, I don't have any fancy metalworking tools, but I do have ingenuity. I think that's the word. Anyways, so I put a bolt here for our pull scale for the turboprop testing, so that'll work good. The turboprop does cover a little bit of the scale, but we'll still be able to read the screen. And then what I did was make this mounting system out of L-bend aluminum, and it bolts to the standard system. And then we've got our mounting system here for the turboprop. Little cutout for the lubricant line, and just like that. So I'm going to get that all bolted up. That should work perfect. All right, guys, the engine is all mounted and ready to go. Now, typically we would have all the stuff mounted on the rear part of the turbine test stand, but because of the wind that's going to be flowing over, I've added some extensions, and we're going to have the stuff off to the side. So we have mounted the prop. The test prop for this is a Fiala classic prop. It's a 20 by 16, and obviously 3-blade propeller. The owner does have a Vario prop as well too, which is probably going to end up on the aircraft. But for this test, that's the prop that we're going to be using. Now, do keep in mind that we are 3,200 feet above sea level where we're testing this engine. So if you are at sea level, your prop is probably going to change. Your amount of thrust is going to change. I add that little disclaimer to every single turbine test video that I do because it does make a huge difference. We normally see about a 15-ish% loss of thrust with our turbines at our altitude. So keep that in mind, please, with any of the tests that I have done ever, or also this test as well too. So let's get this mounted on the stand, get her weighed down, and fire this thing up. All right, guys, so one of the challenges when we're dealing with a turboprop like this is we obviously don't want to be standing in front of the prop. We don't want to be standing beside the prop. So we kind of want to stand behind the prop. But the problem is it's blasting all the exhaust and warm air back towards us. So it's a little bit of a challenge to do the tests on these things. What I'm probably going to end up doing is just taking some still pictures of the max throttle and all that kind of stuff, the max output we get on our scale with this prop configuration, and take it for what it is. I mean, again, as I mentioned, we are at altitude. The temperature today is about 25 degrees Celsius, which is about 80, maybe mid 80s in Fahrenheit. Now, keep in mind, please, that if you are getting one of these engines, please refer to the instruction manual. The instruction manual is full of tons of information. I am not going to cover everything that you need to do in order to get this engine running, so please refer to your instruction manual. Now, this engine right now currently comes in two different configurations. Call it a low and a high. Now, the idle RPM at the prop shaft is going to be on the low 1400, on the high model is 1200. The easy way to think about it is the high ratio, the actual prop driver, the washer that your prop sits against. That's going to be 50 millimeters in diameter. The low, which is the model we have, it's 40 millimeters in diameter, so it's a significant difference, easy enough to differentiate between the two. The high ratio, you're going to get an idle or a max thrust on the ground of about 6,000 RPM. The low, you're going to get a max thrust of about 7,400 RPM. Now remember that when you're unloading, it can unload much higher, and this is all covered in the manual as well. Now, the manufacturer's specs state that this engine should be using 180 milliliters per minute for the full, I'm assuming, full throttle test run. So we will test that as well too. And one of the last cool things that I read in the manual is the gear assembly actually has a drain built in. So that's this plug right here, and there also is a magnet on that to catch any debris that comes off the gear assembly. So the reason this drain's there, what they say in the manual, is if you're storing this for a long time, you can pull the drain out, and there's about a teaspoon of oil that sits in the bottom of this gearbox, and you want to drain that because it can leak out of your exhaust outputs here as well too. All right, so I'm just getting things assembled here. We've got the actual test stand strapped down to the bench. We're going to put some weights on the back of the bench to prevent that from going anywhere, and we just have to do our final assembly here. Now, the RPM sensor right there, that connects to the auxiliary input, which is the bottom one, according to the diagram there. So we're going to get a connector and connect that up. And everything else is pretty straightforward. First thing we have to do is learn this turbine to our test receiver. Okay, so as per most Zukoi Fatics, we're going to program the radio, which is very simple. So stick up, trim up, hit the OK button, stick down, trim down, hit the OK button, stick down, trim up, hit the OK button, and we're ready to go. Okay, so the other thing we can do is we can go to the next screen, and we can see if we trim up, we're at 43%. If we go throttle stick all the way up, 100%. Okay, so that's set. Now we'll go into the other parameters just to check things over. So startup parameters, so we are using kerosene as fuel, so we'll keep that. All the other stuff we don't want to be messing with. And we'll just go into the info, reset the battery. Total time 0, there's the serial number and everything. Test starter. That works. Test glow plug. Usually you can hear this. So you won't be able to pick that up on the camera probably, but it's just a faint little buzz that you hear from the actual turbine itself. Test prime pump. We won't do that yet. We're going to disconnect this though, and we're going to run some fuel through it. Test gas valve. You can hear that click. Fuel valve. You can hear that click. And there we are. Last thing, run parameters. So full power. Oh, that can go higher and higher. So it was set to 3.9. Wow. So at 3.9 it was where it came to, and we just upped it to 5.5, 7.4 horsepower, 225,000 RPM. We'll just go back to 3.9 and see what it says. So 3.9 kilowatts is 201 RPM, 5.2 horsepower. What kind of fun is that? Let's up that thing all the way. All right. Idle speed, auto 66,000 RPM, ambient accel auto. We've measured out the 180 milliliters of fuel that it's supposed to run on for 1 minute. From the measured tank, the fuel line has been primed, the intake for the pump, and the fuel has been drained to just where the plug starts sucking up air. And I'll add the 180 milliliters of fuel to the test tank. All right, guys, we are ready for the first startup. We've got our stopwatch ready to go for our test. We've got the other camera for some random pictures of the whole computer or display setup. Let's start this thing up. All right, so I just realized it said error because I forgot to put the connection on the RPM sensor. So we're gonna get that sorted out and we'll restart it again. And you can see there, it flashes very rapidly. I'm just gonna put a little bit of Velcro around that to keep the line clear, but we got everything set up now. All right, well, guys, quite honestly, that's scary. Really is. There is a if my telling you this is really going to convey this, but there is a ridiculous amount of air coming behind there. I can't even hold my phone still, as I'm sure it's going to show up on the videos. So I know I haven't got to full throttle yet. So honestly, it is a little bit scary, and I don't think that I'm going to do the full throttle fuel consumption test on this thing, because when I go to full throttle, it goes up to about 210, and then it's slowly climbing to 225, which is the max where we put it. And I don't think we're going to be able to test the max on this thing. So it's definitely pretty scary. At least I won't be able to test the max and show you guys the display. I can probably test the max, but I won't be able to show you guys the display, just because when I'm right behind there, there's just too much wind, too much going on. So I'll see what I can figure out and see if we can make this this work, so we can at least do the fuel consumption test, and maybe I can see what the weight gauge or pull gauge is telling us we're getting. All right, guys, we're going to try this one more time to do the full throttle fuel consumption test and see how this goes. I do have it weighted down, and it's going to be a little bit scary, sketchy, but hopefully this works. All right, guys, well, we were not able to get the full throttle fuel run. I honestly forgot to push the timer, and there's just so much going on. It's pretty freaky, but it did run amazing. The turbine didn't even get close to the max RPM, the 225,000 RPM, and it was already hitting that 7,400 mark or 7,000-ish mark. So this could have a way more aggressive, larger prop on it. No problem at all. So anyways, it's an amazing little turbine. It really is. Unfortunately, we don't have any real data as far as thrust figures and anything with that prop. We easily hit mid-20s, 25 pounds of thrust, which was no problem. But I didn't get a picture because there's too much turbulence going over everything there to get a picture. All right, guys, so my final thoughts on this engine, let's go over it. So one of the things initially that I noticed when I was running this engine was when the prop is installed, the prop spins nice and true and square. The output shaft is nice, true, and square. One of the problems is when you put this bolt on the end, it is not sitting level. So I'm not sure if it's the shoulder on the bolt or what's going on, but you can see it when you get to the point and you tighten this down. The prop washer here goes sideways a little bit. So just something to keep in mind. If you're purchasing one of these, just maybe make sure you take a look at it and see. That's one of the first kind of issues, if you want to call it that I noticed. And we need to rectify that. And we are probably putting a vario pitch prop on this turbine on the PC21. That's one of the next projects on the channel is we're going to be installing this turboprop into a Sebart PC21. So overall, very, very impressive little engine. I have a feeling that Zukoi is going to be the new benchmark for turboprop engines. With this design, the beautiful craftsmanship, this rigid structure, the output system, everything on it just works amazing. So very, very impressed with this little engine. I love the RPM sensor, and that is a great little feature that shows up on the brain unit. It's not on the home screen. The home screen shows the turbine RPM, but if you go to one of the other screens, you can see the prop RPM. Now, unfortunately, we were not able to find out the max thrust with that prop at 7,400 or whatever the max bench RPM is. Yeah, it was, number one, too scary. Number two, there was just too much wind being pushed. So just some rough guesses. When we got this engine, we were at 201,000 RPM was the max. I can't remember the exact number, but it's in the video. I'll post it down here of what I covered earlier. And we initially bumped that up to 225,000, which was this power setting here. And that was way too much for that prop. Now remember, this prop was a Fiella 20 by 16, and we would have to turn this down to a substantially lower number for that prop to work with this engine. So I think we were about 210,000 RPM when this started maxing out at around that 7,500 mark. If I would have let it continue to climb to that 225,000 RPM, I mean, it would have been off the charts. Very impressive little unit. If you guys are looking for an amazing little turboprop, definitely check this one out. I am a Swiwind dealer. There's a link to my webpage down below, but I try and keep these turbine tests non-biased. I like to have some benchmarks of quality that I like to see and some expectations with how these machines run. So that's it for this test, guys. If you do have any questions, you can post them down below in the comment section. You can also reach out to me on my email. Email is listed down below, thelightersideofrc@gmail.com. I do read all my emails and all the comments listed down below as well too. And love to hear questions and comments from you guys. So thanks guys for tuning in to this turbine/turboprop test video. Don't forget to give the video a thumbs up. Hit that like button. If you haven't done so already, hit that subscribe button down below. Keep your eyes and ears open for the installation of this in the PC21. And if you want to be notified of my next videos, you got to hit that subscribe button down below and hit the bell so you get notified when I release new videos. Thanks guys for watching, and we will see you in the next one.